All right, let's get started. I don't know if I have the energy for this. This is a rough day. All right, let's get started. So today this week. All right, my brain's going to do this. We're gonna do this. So this week we kind of have a little bit of flexibility in the week itself. There's not 3 full lectures worth of content, which after going through OAuth and all that stuff, I think we can use a little bit of a downshift. So luckily this week comes at the right time in the schedule. I'm starting to look at spring break. We got 2 more weeks. We can get there. We're going to make it because I'm running out of energy. But we have a little bit of flexibility in this week because there's not so much content. So in the other lecture, I went on other stuff. I talked about other stuff till 35 in. So 4:35, that's my target. That's when we're going to start slides. If not, a little sooner. I mean, if there are no questions, I won't. But I want to start with the router. Yes, the router is seemingly causing tons and tons and tons of confusion. So I want to talk about the router and give examples of that. Even though it was covered in every single recitation last week. Seriously, y'all, go to recitation. There's really good stuff there. But I'll devote a little bit of lecture time to it because the router wasn't meant to be very complicated. It's just part of LO1 of the homework. It's not supposed to take up too much time. But I feel like a lot of students, well, not even just feel, from the office hour questions and things that I've seen with the router, a lot of y'all are overcomplicating the hell out of this thing. So I want to make it clear what I'm asking because I got to update the wording too, which is a little late this semester, but for next semester I got to update the wording of this objective to make it more clear what I'm asking for, but I can do that in lecture right now too. Where do I want to start? In the router itself, I never require you to actually use the router. I will strongly recommend it. The idea of the router is to start encouraging better architecture in your software and in your server, better code organization, things like that. Historically in this class, by the end of the semester, by the end of all the homeworks, most students have one giant server.py file where all of the code is in the handle method, and it gets to be about 600 to 800 lines of code, usually sometimes pushing 1,000 lines of code in this one file. And students will come to office hours towards the end of the semester working on some of the last objectives, and they'll sit down with me or the TA and say, why doesn't my code work, which is a typical office hour visit. And we'll say, okay, so what's your intent? Like, what is this code supposed to do? And they'll go, okay, well, if this conditional is, we're doing WebSockets, and this conditional is checking for WebSocket paths, and if this is true, then, and they'll scroll 400 lines of code, zip by. Then it'll get to this point right here, and then this code will execute, and then if this is true, it'll call this function, and they'll zip up a couple hundred lines and say, then this will happen. And it's just an absolute mess. Sometimes they'll have a giant loop that's hundreds of lines of code, and each iteration of the loop will do something different, like looking for different values. The end result is that we can't help the student. Like, we will give them 5 minutes of time or something, and there's a queue of 20 students. We're like, look, I can't understand what the hell your code is even supposed to be doing. I got to move on to the next student, and then that student doesn't get help. But if you have better organization, which I always encourage, but if I don't force it, nobody does it. If you have better organization, you can get a lot better help in office hours is one big selling point because your code is legible, and it's easier for us to understand what your code is supposed to be doing, so we can understand why it's not doing that and give you better help in office hours. It's just easier to do, and we'll be able to get there quicker. If Verizon, my router works fine. And this is the other thing I wanted to say there. And the students with better organization, we usually don't get to see them in office hours because their code just works. Like, it's easier for them to debug their own code, and they don't really need office hours as much. But I did, at the end of last semester, I looked at everybody's submission everybody in the class, and like 80% of them were using one massive server.py. It's not like a lot of students were using good organization. I didn't see them. It's true that those 20% we wouldn't see in office hours, by and large. But most of the class won't use organization unless I force it. So with LO1 this semester, I am trying to encourage more organization. That said, the router, I don't actually require you to use it. I require you to make the router, but you don't have to use it. I will strongly recommend it for the reasons I just said. But I think that's part of what went wrong here. When you don't have to see the other side of the router, I think a lot of you are trying to just write the router without thinking about how it's actually going to be used. And those of you that are trying to use it, are very confused about how it's supposed to be used. So I want to dedicate some lecture time and talk about how it's supposed to be used. With that preface, let's talk about it. Yeah, please, seriously, please use the router. And I'll explain, as we go through the demo, I'll explain how it can really help you with your organization. So I have the router imported here, and the question is how to use it. And I've seen a lot of calling add route in the route request method, and the route request is looking like the handle method. If path is this and method is this, then add a route, just a lot of really weird stuff that I'm seeing. And a lot of office hour visits are turning into explaining how the router works. So let's clear this thing up. So I have the router. The biggest thing, I think the biggest misconception is that you're going to add this suggestions. It's getting way too aggressive. I was trying to turn that off. I don't want it to suggest that. I couldn't even find a way to turn it off. I thought I did, but because how do I indent? Tab does that. I just want to indent, and I guess I have to hit spaces. Don't want it to write my code for me. The router is going to be created, and you're going to add every route for your router before handling any requests. Before any TCP connections are even made, you're going to call add route for all of your routes. That can happen in a few places. You can do that right here. Create your router, and then start populating your router. I feel like I go into settings and I say don't do anything. Those suggestions as you type. Full line suggestions. Yeah, or I just don't use an IDE. Might be the answer. So you can do that right here. This is one thing that I don't really know. I just don't know. But a lot of y'all haven't done OOP in Python. And I don't know if we should dedicate 312 time to that, or I really think that should just be left to your own devices. If you made it through 116, transferring that over to Python should be pretty straightforward. But I'll do a little bit of it right now. If I create this router right here, I'm creating a variable out here outside of all the methods in Python. In Java, this would create an instance variable. In Python, this creates a class variable. So this router belongs to the myTCPHandler class, which in Java is the equivalent of a static variable. So this is equivalent to static router, or whatever. I don't want to do the whole line. But creating a static variable named router of type router. That's the equivalent in Java. In Python, you just put your variable out there where you would think it'd be an instance variable in Python, but it's a class variable. To create instance variables, you would have to create a constructor. Oh, now I turned off all my suggestions. I wanted this one. The wrong syntax. Oh, yeah. No, that's fine. If you create a constructor and do self-dot variable name, that's going to create an instance variable that belongs to that object. But we don't really want to do that. That is, for what it's worth, how I did my router to begin with, but in hindsight, it was a really bad way to do it for several reasons. One, it's more complex, and two, it wastes memory because we only need one instance of the router. So we can create it here, or just put it up here in the globals. We can create one global router. This is fine too. This is at the package level. So anywhere where we have access to our server.py, I put this in a separate class for the example, of course. But everywhere where we have access to that file, we can import the file and access our router, which we're only going to need in the handle method anyway. If it's a class variable, wherever we have access to myTCPHandler, the class, we can do myTCPHandler.router and access the router. So either way, it's going to work for you. But you want to create your router before the handle method is even called. Don't create your router in the handle method. That would actually work. It'd be decent, I guess, but kind of wasteful. So when we create our router, then we're going to add all of our paths. Yeah, I turned off all autocompletion. I do like autocomplete. I didn't want it to get too aggressive. I had to just turn off the full line suggestion. But now I actually have to remember things. Add route. And when we add a route, we're going to specify the method. I'm going to add a get route. And if I want to add a route for my home page, I'm going to do slash. Let's start with a different one, because I started with the home page last time and I had to talk about regex right away. Public slash functions.js, and then a function that's going to take a request and return bytes. That's going to be your response. And that part's a little trippy. We removed functional programming from 1.16, so a lot of you probably took it without functional programming. If you didn't take 305, you've probably never seen functional programming. So when I say write a method that takes a function, bless you, that might be a little trippy at this point, and that's fair. That's going to be a little trippy. But this is what I mean by that. We want a function that's going to take a request, and I'll call this just serve.js. It's going to take a request, and it's going to return some, I don't want to do the full response, but it's going to return the bytes of your response. This would be like http:/1.1/200 OK/r/n, .. Whatever your response is. And before that, you would read the file. So you're going to take a request. In this case, just serving a static file. You don't actually need the request at all, but for some paths, you're going to want a function that gets into the request, checks the path, extracts query string parameter, whatever you need to do in that path with that request. In this one, if this function is being called, I know I'm just serving my JavaScript. So I want to pass this function as the third argument. I called it server.js for some reason. Serve.js, importantly, without parentheses. You're not, bless you, you're not calling the function, you're passing the function itself. So I wrote a function, and I'm passing a reference of the function to my method and giving that to the router. And then the add route method here, what the add route method should do is pretty much nothing. It takes these three values and stuffs them in a data structure somewhere for later use. And that's it. Your add route method shouldn't really do much at all. For my money, I created a route class, and I create instances of that class so I can name my 3 instance variables. If you don't want to even do that, you can put these 3 variables in a list of size 3 and stuff that in another list which stores all of your routes. That's fine too if you want to do that. It's not recommended. It's not the best practice, but it'll get your add route. What add route needs to do is get these 3 values in a data structure somewhere. Yeah. This one? No, because I'm not calling the function. When I route the request, that's where I'm going to call the function. Here, I'm passing the function as an argument. So I want the whole function itself passed as an argument. And then, let me give an example of this. This is a good question. I'm just going to write some dumb function here. So I want a function that takes a function as a parameter. This is something that we can do, right? some function that does something, and maybe this takes a parameter x. And I don't know, print x. You would never actually do this. I'm just doing this for an example. And then inside call function, maybe I want this to take an, I'll just take func. And then inside this function, I can call this other one. So I want to call func of 7, which will call the function something with the argument 7, and then print 7 to the screen. If I do call function something, I don't give something a parameter list because I'm passing the entire function, and then inside call a function, that's where I'm actually calling something with the value 7. And if I run this, I'll run my server and everything, but before running my server, it's going to print 7 to the screen because I call this function with a reference to something, and then this function called something with the value 7, and then something printed 7 to the screen. So I'm passing a function. I'm not calling the function. I'm giving it the entire function. And that's the same thing we're doing here. I'm giving it the entire serve.js function, and then when you call route request, inside route request, that's where you're calling the function with the request. I guess that is really trippy if you haven't seen that before. But functions are just like any other value. Once you can get over that, then a whole world of functional programming opens up to you, to be honest. It's really cool. It's really fun stuff. But functions can be passed around your code just like anything else. In certain languages, you can't do this in Java, for example. But in Python, JavaScript, I shouldn't have started listing things, but in a lot of other languages, C and C++, but it's a bit more of a pain to do. Scala, that's why we used to use Scala, because it had nice functional programming support. Yeah, and 305 for sure. Take 305. I think we're making 305 required again, right? It is now required again? Yeah, so y'all should take 305. Especially since we removed functional programming from 116. Y'all need some 305 in your lives. Yeah. Rather than inside here, you'll get the same effect there. I would prefer inside the class, honestly, to not muddy up the, this isn't really global, but not muddying up the space up here. I don't like having code up here for my money, but either way is going to almost have the same effect for you. Yeah, there's a bunch of questions. Let me get further in the demo here. And then we'd have like public style.css, and this would be like serve CSS, serve CSS, serve HTML. And then I'm not going to change these functions, but that's where you would actually do your pathing, or not your pathing, but you're reading the file, creating the request, getting the content length, the content type, setting everything up, and then returning these bytes. So serve CSS, and then for your home page, that's where we're going to start using some regular expressions. Ooh, the big scary word. That's just hearing that word has been freaking everyone out, and I want to dispel a lot of that scariness. So at the home page, we'll have this path where we want to match just slash, and I'm going to use the $sign here. This is part of regular expression syntax that's going to say this has to be the end of the string. So inside your route request method, you'll match the path using re.match, and that's really all I'm asking you to do to support regex. Call re.match, import re, the re library for regular expressions, and call re.match. I shouldn't even mention anything about the caret, to be honest, in hindsight, in the homework document. You can add the caret to your regular expression. The caret means this has to appear at the start of the string, But if you use re.match, it adds the caret in there for you, so you don't have to mess with the caret. If you're using re.match, you don't have to mess around with carets at all. But if you're using re.search, I used to use re.search because I was dumb. I didn't know match did exactly what I wanted it to do. So I did search, which matches anywhere in the string, and then I added a caret to the beginning of everything. So if you use re.match, you don't have to worry about the carets at all. So I'll be matching at the beginning of the string, start at the beginning. re.match is going to do that for me. The beginning of the string has to be slash, and then that has to be the end of the string. So what this is doing is saying if the path is exactly just slash, then match that and call this function. So if I get a request, it's a get request for just slash. This is the function that's going to handle that request. I'm going to call that function with the request. It's going to return the bytes, which should contain my HTML. And then that's what I'm going to return to the user. That's what I'm going to send to the user. If I don't have this $ here, this is saying any path that starts with slash route to this function. Well, guess what path matches with slash? Bless you. All of them. Every path starts with slash. So if you just have this without the $, everything's matching slash. You can make that your last path. So you're going to say if it doesn't match any of the other ones, then match it to slash. But then you don't have a 404 because nothing's going to fall through to your 404 if you have just slash. But if you have slash $, then you can get this one. And we can start using some more regular expressions, which you don't need to do. Again, you don't need to use regular expressions to get through LO1 of homework 2. You have to call re.match, and that's it. If you never use a regular expression, you can get through. But if you are using this server, which I highly recommend, this is how your router, this is how I would recommend using it. There are a few paths where you want multiple paths to match the same route, like public/image. Anything that starts with public/image, you want to route that to the same function, your function that's going to route the images. I do recommend, if you want to do something fancier, go for it. But I do recommend hard coding these files. We don't have too many static files because each one of these is going to have a different MIME type, and you can specify the MIME type in each individual function. For your images, every image is going to have the same MIME type up until AO1 of homework 3, right? They're all going to have the same MIME type. So if you have one path that says if it starts with /public/image, then do serve image. And here's where you can use a regex. This is going to match because if it starts with the string, it's going to match. So whatever's after this, but it's going to be slash and then some file name. I like to add this /dot. The dot in regular expressions is going to mean anything except empty string. So I'm saying if I get a request for /public/image/something, that something is going to be the file name of my image, and then my function, my serve image function, can look at the path of that request, extract the file name, open that file, and then serve that with image/JPEG as the MIME type. So that gives me a little more flexibility. This you honestly don't really need, but there is one case that we do need this. We have a path /getChatMessage. And if you did the AO, I realized I was confusing people in the last lecture, because if you didn't do the AOs for homework 1, this won't make sense. But if you did the AOs, you have two paths. Everyone has /chatMessage. Get/chatMessage is going to return every chat message. That's how we get all of the chat messages from the database. And then in AO1, there was a /chatMessage/ and then some ID. So we have two paths that both start with the same prefix, and we want to route them separately. So a few different ways we can do this. My favorite is this way. I'm going to say if I get a request for /chatMessage/anything, then I'm going to expect that to be a specific message. And I'm going to give this to a function that's going to read what the message ID is and then serve up that specific chat message. And if I get a request that starts with /chatMessage, I'm going to serve every single message. And the order is important here, because this one, your router should check these paths in the order in which they were added. This one will be checked first. So if I get /chat message /anything, it's going to go to my function that looks up that message by ID. And if this one didn't hit and my request starts with /chat message, then I know it's a request for every chat message. And this path could be /chat message or /chat message /. So it's hard to hard code this with the $, but we could do this as well. But we need 2 paths just to make sure that we're getting both cases here. Or we are careful with the order and use it without the $, and then grab this either way. With the $, any order is fine. But this is why we want to use regex, is so we can handle things like this. Otherwise, we can't distinguish between get chat message to get all messages or get chat message to get a specific message by ID. So this is why we want regular expressions. That's why strictly string equality isn't going to work, because we have a lot of things we have to host, specifically when we have image uploads. And there's going to be other cases where we want, and so we could use string.startsWith. We could check, okay, if it starts with this path, then route it. So we can host all our images just by string.startsWith. That'll get you most of the way there, but then situations like this come up, and string.startWith isn't going to handle this case, because 2 requests that start with chat message / need to be routed differently. So with regex, if we support regex, which again is just calling re.match instead of does this string equal this string, in your router, it's not almost no work. And then after that, you have the option to have regular expressions, which gives you this whole huge, powerful thing. Regex, admittedly, it can be complicated. It's cryptic, all these symbols that all have different meaning. I have to look up a cheat sheet every single time I use regex, because I don't remember all these symbols. There's so many of them. But once you have that power available to you, then you can start using these useful regex symbols and have that power sitting there ready to be used. Whereas if you're doing string matching, you do starts with, and then you want to add more functionality. You have to go into your router and update it every single time you want to do something more complex like this. With regex, you have all that power just sitting there waiting for you to use. And I feel like I get pushback every time I say this, but I'm going to keep saying it till forever. You know regex. You all know regex. But you might not have heard it by name necessarily. But in CSE 191, you do regular languages and DFAs. That's regex. Even a lot of the syntax is exactly the same when you go to code with regex. It's regular languages. That's what it is. You've studied this for probably weeks in 191, right? It's a big chunk of the course, ain't it? That you spent a lot of time learning. So even with that, even with regex being scary and everything, it's something you know. Like you learned it. It's a prereq of the prereq of this course, so you should really know it. So it shouldn't be that scary anyway. Even if I had you actually doing regex, which I'm not requiring, you should be able to handle that. Okay, so that's how setting up the router works. And then when it's time to use the router, you should all have code that looks similar to this. We don't need this counter. Should all have code that looks similar to this. You're going to read the request from the TCP socket and then create the request object. The router, I get, is a little bit of a leap. There's quite a bit of reorganization that you have to do with your code to use the router. So I know some of you won't use it. I'm going to strongly encourage it, but it's a little bit of a hurdle. But you should all at least be using the request class. There's no reason to recreate all that functionality you built. Call the request constructor, get your request as an object instead of re-parsing everything, rewriting the exact same code you already wrote. I would expect you all to be at least doing this. So this, at least your code should look like this in your handle method. And then when you have your router, call route request. This is when we route our request. We're going to tell our router, hey, route this request. We get some request. That's going to go through all of the routes that you stored in that data structure and say, does this method of the request match the method of this route? If it does, check the path. regular re.match, does the path match this regular expression? If it doesn't, move on to the next one. Doesn't match this one, keep moving through until one of them matches. Maybe it matches this regex. Call this function with the request, and whatever that function returns, that's what your router returns as the response. If you get all the way through these and none of them match, return your 404, the bytes for your 404 response. So your route request is a loop. You're looping over all of the routes that have been added, checking if the method and path match, where the path is matching based on a regex. And then if they match, call that function, and whatever the function, who cares what the function does, you're just calling that function and returning whatever it returns. And then return your 404 if you ever get to the end of that loop. The entire router, the add route is adding to a data structure, and route request is looping through all those, doing 2 checks. The entire router is like 10 lines of code. If you have more than 10 lines of code, you're going down the wrong path. I mean, unless it's like 15, maybe you separated some things in a few lines. If you're hitting over 20, you're on the wrong path. You're way overcomplicating things. I'm not asking that much here. And then once you have the response, ship it. That's how much code should be in your handle method. I would add some extra code. I would leave in the print statements to print out the requests, because sometimes that's helpful for debugging. But this is all the actual logic that your handle method needs. That's it, 4 lines. I turned it into 7 with some blank lines there. Not much going on here. And then the big advantage, the reason why we set all this up, is we can start separating things into separate classes. Instead of server.py being this massive file, even my legit server.py, I use the constructor like a dummy, but even the full server.py with some extra stuff, we won't even do this in the class, less than 100 lines of code with a bunch of extra crap and some commented out lines and stuff. What we can do is instead separate all of our code, all of our paths, all those functions. Since your router is taking functions, you can put those functions in separate files and start organizing your code a lot better. So when I start with the static paths, and all those static paths, I'm adding my routes and having a separate function for each one of my static paths. And then each one of those functions can be separated, easier to understand. If I get to this function, I know my job is to serve up my JavaScript file, which I have a helper method for because we send a lot of files. I wrote a helper method to send files, to read it, get the right content length and all that stuff. I'm not cut and pasting that code. I'm going to write it one time using my helper function. And for what it's worth, this, I wouldn't, you don't have to do this, but I set up separate functions in each one of these files to add the paths. It takes a reference to the router and calls add route. So now everything to do with my static paths is all in one file. It's all in one place. And I can easily, if I got to debug a static path, I can go right to this file. And that's the only one I'll actually open, but I'll point out the other ones. For the AOs for homework 2, Spotify paths, that's where I put those 2 paths for Spotify. I have the same thing. I'm adding 2 routes for my 2 Spotify paths, and then all of the function, those 2 functions that handle Spotify requests, it's all in that one file. So when I'm working on Spotify stuff, I'm going only in this file, and I'm forgetting that it's even part of a server or even part of a router. I'm focused on just that piece of functionality. Same with WebSockets. When I'm doing WebSocket stuff, I'm just hanging out in this file. When I'm doing Multipart, which is what we'll start talking about today, I'm over in this file. For form uploads, authentication, I can separate my code and make it a lot easier to follow what's going on. So I'm strongly encouraging this structure. Hopefully I can convert some of you over to the good side of structuring your code less crappy. If I can say it. Okay, any questions on all of that? Hopefully that clears up what the router is asking for. I've seen, oh my goodness, some of y'all way overcomplicating it, which with so many of you overcomplicating it, the problem's with my wording in the document. That's why I'm willing to spend so much lecture time on it to clear that up, because that's my bad. But any other questions on that? Does this clear things up? If not, what are your questions? How do I check if a path is invalid? What, do you mean if I get through all of these? Like if I get a request and the path doesn't match any of these? Is that what you're saying? That would be in serve image. I carefully wrote if I'm misunderstanding you, let me know. But you're getting a request for an image that doesn't exist, so the path looks fine, but the image that you're going to get a file not found. Right, so I carefully wrote the homework so you don't have to handle that. Like in the real world, you would return a 404, but we're not going to test for that, and whatever your server does is fine for grading. In the real world, you would have to look that up, but that would be part of the serve image functions job. That would have to try to open the file and then catch, accept file not found exception, and then do your 404 there. I just don't require it in this class. But that would be the functions job, not the router's job. The router's job is exact string matching and regular expression matching, and then pass it off to the function, and then the function does everything else. Talk about LO3. I have 3 homeworks in my head, and I'm starting to think about homework 4, so I don't know which LO3 you're talking about even. But we do have to get to today's content. We're at the 35-minute mark. Oh, we're at 37, so we do got to get to today's content. I'll give a quick answer if you remind me what homework was talking about HTML and JavaScript in LO3. With the cross-site request forgery token, that would be. You gotta have a more specific question, because I could go on for half the lecture. And I did when we talked about it the first time. I would need a more specific question. Since it's off topic, I'll still give a quick answer, but I need a specific question. All right, so let's at least make sure we got to this slide in the other lecture, so we got to get to that one, slide 12. Multipart parsing and file uploads. And slide 12 is enough that we need for the lecture question, too. It's kind of the perfect stopping point. So let's talk about multipart parsing and file uploads. So last time we talked about HTML forms. This is where we're at. We're going to have to pick up this conversation. We started with HTML forms where the method was get, and we saw that it was going to URL encode whatever the user typed in, and then put that as the query string right in the path, right in the URL. We changed the method to post, and that took that query string, kept the URL encoding, and put it in the body of the request. And then last time we got to this point, we diverted over to AJAX. We said, forget HTML forms, and we just had an input and a button, an actual button, not an input of type submit, but an actual HTML button, and we didn't have a form. And then we used JavaScript and AJAX and JSON to send our chat messages over to the server. So we kind of diverted away from HTML forms. So let's pick up the HTML form conversation. And this is where we left off, because this is what we are currently using. I assume a lot of you are still doing the homework. This is what we're currently using for registration and login for homework 2, is you'll get post request with a query string, URL encoded parameters in the body of a post request. So that's what we'll get. And then we have to mess around with percent encoding and all that. And I limited the number of special characters by quite a bit, but it's still kind of a pain dealing with URL encoding. So when we continue this conversation, we're getting away from URL encoding. Spoilers, we're not there yet, but that's what's going to happen. So with this, when we just changed the method to post, or when we used get as our method, we had the default encoding type, this enc type, short for encoding type. Our encoding type is application/x www form URL encoded. I'll just say URL encoded for short. I'm not going to say all that every time. But this is the actual MIME type that we get. When you look at those registration login requests, this will be the MIME type, is this URL encoded MIME type. Because that's exactly how the data is coming. It's coming as a URL encoded query string, but in the body of a post request. So if we don't specify any encoding type, that's what we get. We didn't specify any encoding type before, so that's what we got. But we do have other choices for this. We can change this encoding, and we actually have to change this encoding. If we try to upload a file with URL encoding, it will not work. The browser is going to take that file and send just the file name. So if we had a file input of name file, we'll get file equals and then the file name only, no contents of the file, which is almost never what we'd want. I can't think of a use case where that's what we want. We want to ask the user to select a file that they're going to upload, and we only want the name of that file and not its contents. That's never our use case. And technically, we could, with URL encoding, we could send the entire contents of any file. URL encoding is % and then 2 hex characters to represent a byte. So any arbitrary bytes, we can % encode. Like we technically could send anything in a URL encoded request, but no browser will. If you have an HTML form that's URL encoded, the browser will not send the contents of that file. So if you've ever done web development before and you had a use case where you wanted users to upload files, you're going through some tutorial or whatever you're going through to learn how to do that, the server, the framework on the server side is going to say, yeah, here's how we handle files, access these variables, this is where the contents of your file are going to be. Oh, but also you do have to head over to your front end and update your form to use multi-part encoding. You change the encoding to multi-part. Oh, we're going to do multi-part. Change your encoding to multi-part, and you need to do that to actually send the file. And you might be wondering, like, why do I have to change that? Why can't I just use whatever encoding type before? You have to add this to your forms. It's because the browser will not send the file content if you don't use multi-part form data as your encoding type on your HTML form. So we're going to change the encoding type to multi-part form data, which I'll usually just call multi-part. We're going to use multi-part as the encoding type, and that's going to send this information in a different format. It's not going to be URL encoded anymore. It's going to look like this big jumbled mess that you're going to learn to love. These multi-part requests are going to look something like this. We're going to have a boundary specified in the content type, and then that boundary is going to separate each part. Then each part is going to contain the name of that input and the value that the user inputted in that input. And notice that our exclamation point is not % encoded anymore. We can use any encodings for this, any, sub-encodings for each part. We can send any type of data this way, which is really convenient. So now we have each part separated by this boundary, and we parse each part separately. Now the browser will send the contents of a file. So we have to change our front end to support file uploads because we need this file upload functionality on the front end, some way for the user to be able to select a file, for that file to be read on the front end, which I said isn't something we can even do in JavaScript, which is still true. We have to do this somehow and build all that functionality. To do that, we're going to go to one of our inputs in the type instead of using text. We're going to change the type to file. Done. That's it. Now we support file uploads on the front end. Most of the work is going to be on the back end, parsing these multi-part requests. But on the front end, we change type to file, and that's it. When we have an input of type file, what this will do is it'll put on our form one of those buttons that says upload a file or whatever it says, I forget. And when the user clicks that, that's when they'll get their file picker. They'll be looking at their file system. They'll be able to choose a file and then click, yep, upload this file. And then that file gets added as part of their submission for that form. All of that is done by the browser itself. So the browser is looking for inputs of type file. And the file picker that you see is based on your browser. That is built into the browser. We as developers, have no control over that file picker. It's all done by the browser. And that's how we maintain some security. That's consistent for the user. So whenever the user sees that file picker, it's the same file picker every single time, unless they switch browsers. It's the same file picker every time. And there's no way for a user to upload a file without looking at that exact file picker. So it's very obvious to the user if we're trying to read a file from their hard drive. It's very clear because we have to go through the browser, and the browser is going to let the user know, like, hey, the site's trying to grab a file select the file that you want them to grab. It's not going to let us just go in and navigate their file system and read files. The user has to approve it through that file picker. And every single site's going to have the same one. So if you use Firefox, any site you go to is going to have the same file picker because it's part of Firefox. If you switch to Chrome, every single site ever is going to have the same file picker. And it's going to be different than the Firefox one. It's going to be the Chrome one, but it'll be the same because it's part of your browser functionality. But anyway, this is all we do on the front end. Type file, browser takes care of the rest for us. We better have multipart as our encoding type, or else the browser's not going to send the contents of that file, just the file name. And then we'll finally get a request like this. So we'll get a request with all of the parts of the form. Every input of the form will have a separate part of the request, technically except for the submit input. This input's not going to have anything. And we'll have the actual contents of the file, the bytes of the file. We'll get the original file name of the user. This used to be all we would get if we were using %URL encoding. We get the actual file name, the type of the file, and the actual bytes of the file in the body of a post request. So this is super handy. We can actually support file uploads this way. In no other way. We can't get these files. Can't get these files any other way. So if you want to build a site with file uploads, multipart, got to do it. Not entirely true, but that's pretty much the only way. So when we're reading these requests, we're going to have the bytes of a file in the request. And for our purposes, from LO2 on homework 3, these are going to be images. And one thing we know about images from sending images to users, now we're getting images from users, is that images do not follow any text encoding. These are not UTF-8 strings that we're getting. UTF-8 has a very specific encoding. And PNG, JPEG, MP4, GIFs, they all have different encodings that will not match UTF-8. An image or video is not going to match the same encoding as UTF-8, so it will not decode properly. If you try to treat that file as a string, you will corrupt the data and probably even crash the dictionary. I'm swearing up and down. They can spit this shit's hilarious. It's time to put these as a string. We have to be very careful about the bytes of this file that we never treat it as a string. So we have to parse in the world of bytes instead of the world of strings, and that's where